Hello everyone. The title of this video is section 8.1 on understanding radical expressions. So in this video I'm going to be going over a version of the section 8.1 Knewton Alta homework. Now please understand that the version I'm doing in this video may or may not contain some of the same questions you'll see when you work on the assignment yourself. But the objectives will be the same, the types of questions you're working on will be similar, and the way you would go about doing the questions would also be similar. And one other thing that I ask is whenever a new question pops up in the video, pause it and try to work on it yourself first before you watch me do it. Because if you're just watching me work on these things and not practicing yourself, well, you're probably not learning all that much, are you? Alright, so here we are on the assignment page. Now you won't see the words preview of. Right, you're just going to see the title of the assignment. You have your mastery bar that shows you how far along you've gotten in the assignment. And the objectives. Right. Now, there are 3 objectives in this assignment. And below each question there should be a feedback button, right, in which you can send feedback to Knewton. You will not see the instructor cheat button, right, that's just for instructors. But you will see the more instruction button, right, and you hit this when you're struggling, and you'll see some reading material, some videos maybe, that are related to the objective that you're working on, and hopefully it helps you. Alright, so the first question here is on simplifying a variable expression with even or odd roots. Alright, so I'm going to write this out, and before I actually get into this question here, I want to talk about even roots and odd roots, or even radicals, odd radicals, right? Remember the title of the section is Understanding Radical Expressions. Radicals are these roots. Okay. So first I'm going to go into a little bit of a lecture here on radical expressions, or roots. So every radical expression has this symbol in it. This is called the radical symbol. Right, or the root symbol. Alright, then in the little crook of the symbol, sometimes there will be a little tiny number. So maybe like a little n, right? Like a 3 or a 4 or a 5. This is called the index of the radical expression. Then underneath the symbol is what you're taking what's called the nth root of. You're taking the nth root of, and then some expression in here. Now I'm just going to use a letter, say m. And this expression that's underneath the symbol or inside the symbol, this is called the radicand. Radicand. Alright, now what I'm going to do, what we're going to do is break this up into 2 cases. The way you express roots, the way you simplify roots or simplify radical expressions is different depending on the value of the index. So first case, if the index is even. All right, so that means 2, 4, 6, 8, and so on. So you're seeing now if you're seeing this symbol, now if there's no index, if there's no little number written there, this means, you know, square root. The index equals 2. All right. But any higher root, you're going to see a little number here. You know, if there's a 4 there, that's the, you know, 4th root. Right. N equals 4. The index is 4, and so on. You'd see 6th root, 8th root, 10th root, etc. All right. So I'm going to point out something right now. When you see this symbol, the square root of, you know, m, this symbol, square root, 4th root, 6th root, they're asking you for what's called the principal. The principal, which is a non-negative. The non-negative square root of m. Because you should know the following from earlier. Right. Every positive real number, right, every positive real number has 2 even roots. Right, has 2 square roots, has 2 4th roots, 2 6th roots, etc. 1 positive and 1 negative. For example, 16 has 2 square roots, and those would be 4 and negative 4. All right. The one that's not negative, right, the 4, that's called the principal square root. The principal root, right, principal square root. The other one is the negative root. So when you see this symbol, again, when you see this symbol, so if I say square root of 16, when you see this symbol, they're asking you for the principal root only. Okay? So the square root of 16 is simply 4. If you wanted the negative square root, you would just put a minus sign in front of the square root symbol. Okay, so the negative square root of 16, or the opposite of the principal root of 16, is negative 4. That's where the negative 4 would go. These are not both the same root. All right. So please, when you see the square root of something equals, something else, say equals some number x, this is the principal root. This is not negative. It must be the principal. Okay. So this is huge. All right. So when you see and this goes for any even root. All right. This goes for any even root. For any even root, square root, fourth root, sixth root, etc. The nth root of m is the non-negative one, not negative, right? It is the principal, what is called the principal root of m. Right. So one more example here. Say I asked for, what's the fourth root, the principal fourth root of 81? All right, this would be equal to 3. Just 3, not negative 3. All right. I know that negative 3 to the fourth power is also 81, but we want the positive one, right? The not negative root. And the reason this is because, right, since 3 to the fourth power is 81. Right? And if you wanted the negative root, right, we know that negative 3 to the fourth power is also 81, but that would be the, negative 3 would be the negative fourth root of 81, right? Negative 3. Okay, so again, one more time. When you see an even root symbol, if there's no negative sign in front of it, the output is not negative. You're asked for the principal. That is the symbol for the principal root, the non-negative root. All right, and then one more rule here. You might have guessed from here. If the nth root of some number is another number, then that means that x to the nth power must be equal to m. Right? So one more rule here. Lots of rules, I know. Right? Okay. Now the fact that when you do this, right, when you take an even root of something, it's got to be non-negative. That leads me to the following. Right? So I'm going to throw out some more examples. Right? So some more examples. The square root of 25, right, is 5, right? And that's because 5 to the second power is 25. Not negative though, right? And I get it. I know that negative 5 squared is also 25, but we're asked for the principal square root when you see the symbol. I can't say it enough. Right? Now how about the square root of a negative number? Now the square root of 0 would just be 0, since 0 to the second is 0. That works. And that's the only number that has one root. Right? The square root of 0 is 0. The square root of 25 is 5, yes, but 25 also has a negative square root, negative 5. But again, the symbol means give me the positive one. Right? When you see the symbol without a negative sign in front, you want the positive one. What about negative numbers? What if the radicand was a negative? How about the square root of negative 25? Wow. Can you think of a real number can you think of a real number whose square is negative 25? Right, meaning this. Right, can you solve this equation? X squared equals negative 25. Well, if I were to solve this, like I normally do, x squared plus 25 equals 0, where I take everything to one side, 0 on the other, this can't factor. Right? This is a sum of squares. So the answer to this question is no. You might have heard of imaginary numbers before. We're not going to get into that here. But the solutions to this equation would be what they call imaginary, right? Not real. So that's all we're going to write. If the radicand is negative and you're taking an even root, we're just going to say that the number is not real. Okay. And write that rule. All right. So the nth root of a negative number where n is even is not real. And that's all we're going to be writing. Because you can't take a real number, you can't take a positive number, raise it to an even power. You can't take a negative number and raise it to an even power and get a negative result. That can't happen. All right, so we have lots of things so far, lots of things, right? We have this, right? What does it mean for the, if the nth root of m is x, then x to the nth is m. That's for any root, even or odd. If you see that symbol, right, the even root symbol, the response should not be negative, right? It's the principal root. And if you see the even root symbol and there's a negative number inside, a negative radicand, the result is not real, not a real number, not positive, not negative, not 0. It's imaginary, and we're not going to get into imaginaries just yet. All right, so now I have one more thing to do with even roots. All right, even roots are, I feel, the most confusing ones. Right, one more thing about even roots. Let's do some more examples. Let's evaluate the following. Now, how about the square root of 3 squared? Well, 3 to the second power is 9, so that's the square root of 9. And remember, the square root of 9 is not negative 3. And I get it. Negative 3 to the second power is 9, I know. But when you see this symbol, they want the non-negative one, positive 3. Now look at this other one. What about the square root of, and then inside we have negative 3 to the second. Now notice negative 3 in parentheses. Now it's just like any other grouping symbols, right? You simplify what's inside first and then take the square root. So this is the square root of, now negative 3 squared is positive 9. And as we just set up here, the square root of 9, this is the principal. This symbol means the principal, the non-negative square root of 9, which is again positive 3. Right. So the square root of 3 squared is 3. The square root of negative 3 squared is not negative 3. So the square roots and squares don't just cancel. Like a lot of people do that, from old, they might think, oh, the square root of x squared, they might think that this is just x, but that is not the case. This is not happening. Notice at the end, it ended up being positive all the time. See, when it was 3 squared, it ended up 3. When it was negative 3 squared in here, it ended up 3 again, which is just the opposite of negative 3, right? The absolute value. So in order to ensure that we end up with a non-negative result when we see this principal square root symbol, sure, you can undo the square roots and squares, but then put absolute value symbols around it to ensure that the result is positive, that you'll have the principal square root. That is something people very, very, very often forget. Right. And in general, when n is even, All right, when n is 2, 4, 6, 8, the nth root of x to the nth power, right, as long as these are both the same number here, it won't just be x, it'll be the absolute value of x. Right? We want to ensure that this gives me the principal nth root, right, the even one. Right. So please keep that in mind, and you're going to have to put, absolute value symbols in your answers. Right. Now that was all for even roots. All right, that was all for even roots. Odd roots are easy. Odd roots, when you see an odd root symbol, it can be any number you want. It can be positive, it can be negative, it can be 0. The even root symbols, the result has to be positive or 0. It can't be negative. But you see the odd root symbol, it can be anything you want. So I'll show you that. So now odd roots. This is where you have the nth root of something, and n equals 3, 5, 7, 9, right? Odd numbers. Right. Now once again, all you're thinking of, for example, if I said what's the third root or the cube root of 27, you just need to think of what's a number that I can raise to the third power to make 27, and that would be 3. The cube root, the third root of 27 is 3, since 3 to the third power is 27. Well, how about the cube root of negative 27? Now, remember earlier, if this was the square root or fourth root or sixth root of negative 27, we couldn't do it. That would be not real, be imaginary. But odd roots are easy. Every number, and I'll put this note off to the side here, every real number has exactly one odd root. So a lot simpler to think about. Every real number has exactly one odd root. Not a positive or a negative one like the positive real numbers had with even roots. Has exactly one odd root. So there's only one number that I could raise to the third power and get negative 27, and that'd be negative 3. Right, since negative 3 to the third power would be negative 27. And it continues on like this. How about odd roots? The fifth root of 32 would be positive 2, since 2 to the fifth power is 32. The fifth root of negative 32 would just be negative 2, right? Since negative 2 to the fifth power is negative 32. But every single number, every real number has a number has exactly one odd root, one cube root, one fourth root, one fifth root, seventh root, ninth root, 11th root. Right? And the nice thing about this is when you take the nth root of something to the nth power and n is odd, then they do just undo one another, and you're left with x itself. Right? So examples of this, what would be the cube root of of 4 cubed? That would be just the cube root of 64, which is 4, right? Because 4 cubed is 64. So the cube root of 4 cubed, the cubes cancel, and you're left with 4. And the cube root of negative 4 cubed would be the cube root of negative 64 would be negative 4. Right? So you see the cube root of negative 4 cubed, the cubes cancel, I'm left with negative 4. So I don't have to worry about writing absolute value symbols when there's an odd root. Alright, so odd roots, very, very simple, I feel. even roots, if you have that even root symbol and there's not a negative sign in front of it, the result has to be non-negative. So that's why you're going to be throwing absolute value symbols around things. And just be sure that the result of an even root is not negative, and the result of an odd root can be anything. Okay, so back to the problem. All right, now that I've got that lecture out about even roots and odd roots, we're asked to simplify, the following roots here. All right. So once again, I'll write this up, bring it back. Okay. So we have the square root. Remember, this is the principal square root. So my result can't be negative for any value of m. All right. So this is going to be equal to something, some expression that can't be negative for any value of m. All right. So think about it. What's an expression that this is a square root, so you're thinking what expression to the second power would give me 9m squared? Well, you might think, hey, the square root of 9m squared is just 3m, right? Since 3m to the second power would be 9m squared, but you'd be wrong. All right, you're almost right. This would be almost correct. But remember, I want my final result to be something that's never negative, right? A principal square root, non-negative square root. This can be negative, right? 3m is negative whenever m is negative. If you replaced m with -1 or -2, this would be -3, -6. That's a negative number. I can't have a negative result when this is the principal square root. So a very easy fix, just throw absolute value symbols around it. Easy fix. So just do it like you would think normally. What expression to the second power would give me the radicand, 9m squared, and then just to ensure that the expression ends up non-negative, right, because this is the principal square root, just throw absolute value symbols around it. Absolutely fine. So this is what I'm going to be entering, right, this absolute value of 3m. So going back, when you enter things, there should be absolute value symbols here, right, but absolute value, and then inside the absolute value symbols I got 3m, and then submit. If you do not, now you can pull positive numbers, see how they have 3 times the absolute value of m? That's fine, right? Because if you have a positive number as a factor inside an absolute value, you can pull that out, but only positives. And there's some rules of absolute values that I'm not going to get into. They might get into it here, but absolute value of 3m, 3 times the absolute value of m, as long as it's equivalent. Right? And again, they're showing you those rules I was telling you earlier, right? If n is odd, no problem. If n is even, right, you've seen an even root symbol, they're asking for the principal one, the non-negative one. Right? Yes, there's I know there's a positive root and a negative root. I get it, but they want the positive one when you see this symbol. I've said that a bunch. All right, so don't forget your absolute value symbols. Right, that's a huge thing here. All right, next question. So we have simplify a numerical expression with even or odd roots. All right, so I've already done my talk on even or odd roots. Now we just have to think. So here we have 4th root of -81. All right, remember I said this earlier. Even root, 4th root. The radicand is negative. Remember, the even root of a negative radicand, a negative number, is not real. There is no positive number. There's no number on the real number line that you could raise to the fourth power and get a negative 81. Because any real number to a fourth power will be non-negative. So they're asking you here to enter the empty set symbol if the answer is not real, and that's what I'm going to do. Here it is. This number is not real. Even roots of negative numbers are not real, and they will explain that to you, right? Every question, right, whether you get it right or wrong, I forgot to mention this after the first question, right? Every question has an answer explanation after it, whether you're right or wrong. If you're correct, please read it so that you make sure you got it right for the right reasons. Or, they may even throw out some alternate method of doing something that you might find useful for the future. If you got it wrong, definitely read the answer explanations, to figure out why you went wrong. And maybe you can learn from your mistakes for future questions. Alright, so moving on. So another one from, alright, so we're back in the objective. Simplify a variable expression with even or odd roots. So once again, I'm given an even root, square root, right? If there's no index, if there's no number in here, it's the square root. And even root, you see an even root, that's the principal even root, the principal square root. The result can't be negative for any value of z. So let's write this out. So once again, even root. And you see the even root symbol, square root, fourth root, sixth root. The result needs to be an expression that's not negative. So you might think, oh, 5z cubed, right? 5 times z cubed. And if you write that, you're wrong. You're not. You're almost there. Since if you take 5 times z cubed and raise it to the second power, right, that would be 25z to the sixth. But the way this looks right now, right, 5 times z cubed is negative whenever z is negative. And we don't want this to happen. Or if I replace z with negative 1, you'd have this side equals, negative 5. Again, you see this symbol, the result can't be negative. Again, very easy fix. Just, what expression squared, because it's a square root, what expression squared would give me 25z to the 6th? It'd be 5z cubed. And then just to ensure that the result is never negative, just throw some absolute value symbols around it. Easy enough. And that's what I'll enter. The absolute value of 5z cubed. So be aware there's the absolute value symbols down here, and then inside there 5z cubed. Now you could also pull that positive 5 out, make it 5 times the absolute value of z cubed. You could also make it 5z squared times the absolute value of z, because 5z squared would be positive no matter what you plug in for z, but then z itself, I'm not going to get into all that. Right? I'll just put the absolute value around 5z cubed, and that's fine. But once again, I can't say this enough. You see an even root with no negative sign in front of it. See an even root? The result you write can't be negative. It's that simple. Odd roots are fine, right? Odd roots can be anything, positive, negative, 0, it's fine. It's the even roots that are tricky. All right, next question. All right, now we're asked to estimate and approximate roots. All right, so you have to know your perfect squares, perfect cubes, perfect fourth powers. Right, I'll talk about that here in a second. So we're asked to estimate the cube root of 4 between two consecutive whole numbers. All right. So again, I'll write this out. We'll get the cube root of 4. And bring it on some paper here. Now notice that we're talking about a cube root. So in order to estimate this, I need to think of perfect cubes. to help me. Now, perfect cubes, perfect powers are just, expressions to that power, right? Perfect cubes or perfect third powers are going to be whole numbers to the third power. 0 to the third power is 0, which is less than 4. Not there yet. 1 to the third power, that's 1 times 1 times 1, that's 1, which is still less than 4. 2 to the third power is 8, and that's greater than 4. Right. So from these lines here, right, if 1 cubed is 1, that means the cube root of 1 is 1. And if 2 cubed is 8, that means the cube root of 8 is 2. And the cube root of 4 is somewhere in between here. Right, cube root of 1, between the cube root of 1 and the cube root of 8. Cube root of 4 is between the cube root of 1 and 8, as we see from our perfect third powers, our perfect cubes. So the cube root of 4 must be between 1 and 2. Right. And you could actually do this on a calculator. Right. I know you don't need a calculator. I'm just going to do it for this first one. I'm going to enter the cube root of 4 on my calculator, and you'll see it's going to be 1 point something. Right. So again, it's going to be kind of tiny here, but if I hit on my calculator here, there's a math button, and then there's a cube root feature. If I just enter cube root of 4, you see that's tiny, but it's 1.587. Right, that's between 1 and 2. Right, it's between 1 and 2, as was stated on my paper. And those are what we're entering. We're entering those whole numbers. Right, back on the assignment page, saying 1 is less than the cube root of 4, but the cube root of 4 is also less than 2. Right, so the cube root of 4 is between 1 and 2. Yeah. So you just need to know your perfect cubes, and if it's square root, know your perfect squares, 1 squared, 2 squared, 3 squared, and so on. If it's a perfect fourth power, raise numbers to the fourth power, and so on. All right. So just pay attention to the index, right? What root is being taken. All right. Now we're back to just a numerical expression with even or odd roots. Look at this. This is just like the earlier problem. The fourth root, right? You see that little tiny 4 in the index spot? Fourth root of -1. Well, you can't take even roots of negative numbers. All right? If the radicand, if the expression inside an even root is negative, the answer is not a real number, right? It would be an imaginary number, but I'm not going to tell you, what the imaginary number is. We just need to state that it's not real by entering the empty set symbol, this circle with a slash through it. Great. And again, please, once again, read the answer explanations. All right, so back to something similar. Right. Estimate and approximate. So it's another cube root again. So look, I got the page ready for that right now. This time, though, we're asked for the cube root of 2. What's that between? Well, 2 is between 1 and 8. Still cube root, right? So I'm still looking at perfect cubes. 1 cubed is 1, 2 cubed is 8. So the cube root of 1 is 1. The cube root of 8 is 2. And the cube root of 2, that's between the cube root of 1 and the cube root of 8. So this must be between, I'm just going to replace 4 with 2 here. The cube root of 2 is between 1 and 2 also. And if you were to enter that into a calculator, the cube root of 2, it would be 1 point something. But we're not asked to do that, right? We're just, oh, wow. Read instructions. Read instructions. So yeah, I guess I am using a calculator. Estimate the cube root of 2 to 2 decimal places. So my apologies, I thought we were approximating there. Or I thought we were estimating, sorry. So my apologies, so I'll bring the calculator back up. So again, this is a TI-84. You probably have a root feature somewhere on your calculator. I hit the math button, go down to cube root here. number 4, and then a cube root of 2. And it's 1.25999. Now if I round that to 2 decimal places, that'd be 1.26. Right? I hope you know how to round to the nearest whatever, nearest 2 decimal places, nearest hundredth. So yeah, so the cube root of 2 is approximately 1.26. And like I said, that's between 1 and 2. Right? I just didn't read the rest of it. So please read the instructions. Right? Okay. So yeah, use a calculator. Right? Okay. So hopefully you have some sort of calculator. You should be able to, most calculators will have some sort of square root, cube root, or nth root feature, whatever root you're taking. All right. Next question. Wow. Another one. Hopefully one of these comes up from this simplified numerical expression with even or odd roots that I can actually do. Because once again, I have an even root symbol, right? This square root. And then the radicand is negative. The square root of a negative number. That's not real. Now, if it were the cube root of -4, it would be equal to some number. It wouldn't be a nice number, but it would be equal to something, some real number. If it were cube root, 5th root, 7th root, this would have some sort of real number value. But the fact that it's an even root of a negative number radicand, this is again not a real number. It would be imaginary, which we're not going to talk about yet. Okay. Oh my goodness. Alright, so hopefully, like I said, the questions I see aren't going to be exactly the same as the questions you see. I am hoping that you see something other than what I've been seeing. Because every single one of these under this objective has been a not a real number. So you see, again, I have an even root of a negative number. Alright, you know what, let me just write this out. Right. So we have the square root of -16. Now if it were the square, this is not real. Right? Remember, the even root of a negative number is not a real number. But if I had the square root of +16, right, that would just be 4. Right? So please understand, you might see other stuff. If you have the the cube root of 64, this would also be 4, right? Since 4 to the 3rd power is 64. Right? The fourth root of 16 would be 2, right? Since 2 to the 4th power is 16. Like, just please know that this isn't always happening, right? Please know that you may come across other examples where you just got to think of a number who, when raised to that power, gives you the radicand. And remember, when it's an even root, you're putting in the positive version, unless there's a minus sign in front. But if there's an even root with no minus sign in front, your result should be non-negative. Right? And if it's an odd root, it could be negative, right? If this was the cube root of -64, that'd be -4. Right? That's fine. The fourth root of 16 is 2. The fourth root of -16 is not real, right? Because again, even roots can't have a negative radicand, right? So I'm hoping you see something different than what I'm seeing, right? So again, I have something here that's not real. Put the little empty set symbol. Wonderful. All right, so that objective's done. We got 2 more questions here. One of these is on simplify a variable expression with even or odd roots. And once again, it's an even root. Please know that you might see odd roots. All right. So again, let me pull this up. This is the 4th root. Let me get rid of these bottom pages. Right. This is the 4th root of y to the 20th power. So again, you got to think of what's an expression that I can raise to the 4th power to get y to the 20th, right? Y to the 5th power to the 4th power, right? Power to a power, you multiply the powers, that'd be y to the 20th. So this is y to the 5th. But, remember, I've said this so many times, even root symbol, your result can't be negative. So to ensure that, I'll just throw absolute value symbols around that. The absolute value of y to the fifth. Because y to the fifth on its own, right, y to the fifth can be negative. Right? It's negative when y is negative. Right? If you replace y with a negative numbers to odd powers are negative. So that's why I need to throw some absolute value symbols around that. Right. So back here. So once again, be sure you're entering your absolute value symbols. Absolute value of y raised to the fifth power. All right, next question. All right, so another even root. My goodness. All right. So I'll write this again. We have, the sixth root of x to the 18th. Sixth root of x to the 18th. So again, we're thinking here, what's an expression that I could raise to the sixth power to get x to the 18th, and that'd be x cubed. Right? X to the third to the sixth would be x to the 18th. But think again, right? This can be negative. We don't want it to be, right? Even root symbol. That's asking you for the principal sixth root. The result can't be negative. So once again, I put absolute value symbols around this to ensure that my result is not negative, is the principal sixth root. Now please understand that every example I've seen from this objective has had an even root. You can have odd roots as well, right? What if I wanted the cube root of x to the 18th instead? Now this is an odd root, so the result can be negative. So this would just be x to the 6th. And be done with it. Now x to the 6th is always non-negative, but this may be a bad example, but you don't need to throw no absolute value symbols. No need. Right? No need for absolute value symbols. With an odd root. You may need them with the even root, right? Just again to ensure that you're giving the principal the non-negative even root. All right, so understand that you may come across odd root problems. Just be aware of that. All right. So back here, once again, absolute value of x cubed, right? X to the third inside the absolute values there. Okay. Wonderful. All right, then the last objective yet to do. Still have two questions: estimate and approximate roots. All right, so this is just another calculator one. So I already showed you a couple times. I'm just going to enter the cube root of 19 on the calculator. Cube root of 19. I'm not showing you. It's 2.6684 blah blah blah. It says round it to 2 decimal places, so 2.67. If it's 2.668, you'd bump that up to 2.67. And that's all, right? So you're using a calculator for those problems. And then lastly, another one of these estimate and approximate roots. Another one. Now I'll do the whole. You know what? Let me write this out, and we'll talk about what whole numbers this is between again, because this is actually a square root. So I have the square root of 111, so I'm going to be thinking about perfect squares. So square root. So now I'm thinking about, again, perfect squares. So, 0 squared is 0, too small, right? 1 squared is 1, 2 squared is 4, 3 squared is 9. And I hope you know how far, you go till you get to under 111. 10 squared is 100. 11 squared is 121. And 111 is between these, right? So that means the square root of 100, the principal square root of 100 is 10. this line tells me that the principal square root of 121 is 11. And 111, 111 is between 100 and 121, right? The square root of 111 is between these. All right, so if we had one of those problems where we had to enter, the left and right end of an inequality, I would say the square root of 111 is between 10 and 11. All right. So when I enter this in a calculator, all right, and again, it's going to be kind of tiny here, sorry. When I enter the square root of 111, it's going to be 10 point something. And it's 10.535, and it's approximately 10.535. Now the third decimal place is 5, so we would bump this up to approximately 10.54. Right, so 10.54 to 2 decimal places is what they're asking me for. Again, just pay attention, read how many decimal places they want you to round to. Right? So 10.54, and should be done. Great. All right. So again, most of this video here was a discussion on even and odd roots. And I'm also hoping you're reading, section 8.1 from the OpenStax.org Intermediate Algebra 2nd edition text, and watching other videos that you might come across on that related to that same material. All right. As I said at the top of the video, this version of the assignment that I did isn't going to be exactly the same version that you see, right? You might actually see some different examples with odd roots, even roots, right? Different problems. But the objectives are the same. The way I would, the types of problems are similar. I'm hoping you get some different ones, right? Some mixed up, mixtures of ones you can actually do. And the way you would go about them is the same as well. Right? And I hope that whole discussion on even roots and odd roots made some sense, so that you have an easier time working on the assignment on your own. And thank you very much for watching.